Okay, good. Hey, how's everybody going today? Lesson 37 here, exponential transformations. Just kind of giving a quick recap of what we talked about on lesson 36. Exponential growth and exponential decay, basically looking at the base. Okay, kind of goes right here back to the general form of an exponential function. All right, this is going to be y equals, okay, our base to the x. Now, kind of goes through here. It says exponential functions do not have a true parent function because the base value can be different. Okay, the most basic or basic base 2 looks like this, 10, and then again, Euler right here is e to the x. So that's the thing about exponentials is they can have different functions. Now we're going to kind of talk about each function a little bit differently here. Kind of has a couple different things that we need to understand. Now, asymptotes. Understand all exponential functions start with the asymptote right here down the axis. Okay, so that's y equals 0. So again, all three of these would have the exact same asymptote. No matter what the base is, they all have the same starting asymptote. Okay, y equals 0. So right here for your asymptotes, y equals 0. Okay, you go ahead and put that on all of them. Now, intercept. So again, there's not a or there's not an x-intercept because of this asymptote, but there is a y-intercept. And again, what's nice about these exponential functions is all the y-intercepts are the same. So your y-intercept right here is going to be 0, 1. Okay, so 0, 1 is this point right here. And again, that's going to be the exact same thing for all these, which is very nice. Okay, so again, y-intercept is 0, 1, y-intercept, okay, 0, 1. Okay, again, we talked about this a little bit the other day, but the domain is going to be the all real numbers, or you can put that capital R here. Okay, that's fine with me. Capital R, capital R. Okay, now your range. Okay, your range is basically where this line is flowing. So what's nice is this asymptote. It kind of allows it. Basically, the asymptote tells us where it's going. All right. So for example, it's moving in the upward direction. So what's nice about the range is here, it's going to be y is greater than. Okay, you keep that 0 there because again, your asymptote kind of tells you. Okay, what happens. Now, getting into transformations, what's nice about kind of understanding the basic equation, okay, for example, that the asymptotes are all the same, your intercepts are all the same, okay? What you're going to do when you do transformations, we're going to get to that here in a second, but your asymptote's going to move with up and down shifts, and your intercept, that's the point that you're going to move, okay? So, for example, if it moves left 1, up 1, all right, that new point is right there. Okay, so it all depends off of that intercept. That's the point we're gonna move from. So let me clear all this up right quick. So it's not a bad thing. Okay. Again, some of you guys are pretty good with this, and some of you guys still need a lot of work with um, transformations. Now, we'll do this. Try this right here. Okay. Um, it says the graph of g of x is attained by transforming f of x is equal to 10x. Based on your prior knowledge of transformations rules, write an equation for g of x based on the transformation described below. So I'm not going to worry about this function notation stuff, but I am going to worry about the transform equation. So first one, translated up 5 units. So if we thought back, okay, and if I looked at I'm just going to use this for example. If I put a square root graph right here, and I put up 5, okay, I would know that it goes outside the function with the plus sign, okay? So the same idea here, okay? If I have my equation, I'll go ahead and make it g of x. If I go ahead and have my equation here, just like we've done before, okay, and I write my base equation down, and it's 10 to the x, okay? where would the same thing, where would plus 5 go? Well, it just goes behind the exponential. Okay, it's pretty easy. Okay, down 2. So same idea here. Down 2 does not go inside this radical right here. It didn't go inside, so you would put it in the same spot with the minus. So this would be equal to 10 to the x minus 2. Okay, and it says translated right 3 units. So again, going back to our original example here, kind of going back to square roots. Okay, if it's going right 3, remember that's actually going to be minus 3, but it's going to stay underneath the radical. So here, when you're doing it, our equation is up at the top. So our x is up at the top. So I'm just going to put x, okay, minus 3, just like that. Okay, left 8, same idea. Okay, I'm going to stop writing g of x because you guys can write that. Okay, so now it's going left 8. So I put my plus 8, just like that up at the top. Okay, vertical stretch by a factor of 6. So now basically what happens is whatever your stretcher compression is, you got to just put a multiplication sign out in front, or you can put this, you can put it in parentheses, but it needs to look something like that. Now, basically what that's going to do is that's going to put our starting point, instead of it being at 0, 1, whatever this multiple of it is, that's where the new starting point would be. So like, for example, this would be 0, 6 for our vertical stretch if it was, this was our equation. Okay, vertical compression by a factor of 1/4. So I put a 1/4 in front now. And then last but not least, reflection about the x-axis. So now you'd have a negative out in front. Okay, so those are the basic transformations right there. Again, not terribly hard if you understand transformations, but again, you got to go back and think about all the different transformations we've done. The thing is, they have not changed. Okay, the up and down goes outside of our equation. Okay, the left and right goes inside of our equation. In this case, it's in our exponent. All right, our stretches and compressions, they go out in front. Same thing with our reflection about the x-axis. Okay, going into a little bit more detail, the left and rights do not change anything. Same thing with the vertical stretch and compressions. Okay, the only thing that's going to change some things, and you'll see here in a second, is really going to be our up and down shifts. Okay, our up and down shifts, that's what's going to kind of change a lot of our graphs. All right. Now, I'm not going to get too crazy detailed with some of this stuff. We will look at some different things, but I'm not going to get too crazy with it. Okay, so verbal description. So first of all, I know it's base 2. That's not that big of a deal right now. And then I got x plus 3. So that's actually going to tell me to move. That's going to go shift left 3. Okay, and then the minus 6 is going to tell me to shift down 6. Okay, again, going back to basically what we were talking about earlier, you're basically going to start at this point. Okay, we're starting at 0, 0, and then we're going to go down left 3, 1, 2, 3, and then down 6, 1, 2, 3, 4, 5, 6. Okay, now basically what happens is there's going to be your line, your asymptote line. Okay, and then again, you can just kind of draw a rough sketch. Doesn't have to be perfect. You guys can use Desmos, whatever you need to do to get that graph. I'm not really going to worry about the table right now. Okay. Now, the asymptote earlier was y equals 0. So if it goes down 6, now my asymptote, and I'll put it in text. Now my asymptote is going to be y equals -6. I mean, it's basically just following along. Okay. Domain is still going to be R. So that's never going to change. Now, range, again, a while ago, our range was y was greater than 0. So again, we moved down 6. So now it's just y is greater than -6. So basically, whatever your shift down is going to be, that's what's going to change your asymptote and your range. If there's not one, it stays 0. So that's not too difficult to understand. Okay. Again, but it's all based off of the equations that you're given and then how they're written. Okay, so again, shouldn't be a terrible understanding here. Okay. Now, these aren't near as bad. I'm not going to fill out the whole thing here for you guys, but we can talk a little bit about it. Again, we'll just kind of highlight some of the main important parts here. Again, I'm not going to fill out the domain because it's going to be all real numbers every time. You guys can put that on there for yourself. Now, verbal description again. I know it's base 10. That's not really affecting the problem. I got an x plus 1 up top. So now this is going to be, I'm just going to shorthand it left 1. Okay. And then the plus 4 at the back is going to tell me up 4. Okay. So again, these two right here, range and your asymptote, is changed by the up, not the left or not the right, but the up and the down. So right here, range, okay? Again, it's going to be y, and now it's plus 4, so it's going to be y is greater than 4. This asymptote changed. Y is equal to 4, okay? It's really simple, okay? Now, B is a little bit more difficult in a sense, okay? Now, there's a lot of different things happening here, okay? The base here is actually the E. So there's actually 3 things that are happening. You got the negative in front. So that's actually an x-axis reflection. Okay. And you got the 2. That's a vertical stretch. Okay. And then you got the x minus 6 up top. So that's actually right 6. Okay. Domain's not going to change. This time the range, because we did an x-axis reflection, basically all you do is whatever this sign is, you would flip it. So now it would be y is less than. There wasn't an up or down shift. Same thing here with my asymptote. Be y equals 0 because there was no change. That number doesn't change. The only thing that changes is our sign, again, because it was an x-axis reflection. Okay, looking at C now. Again, I see the base is 2. I got the little multiplication sign out in front with the multiply. This is actually going to be a vertical compression. Okay, then I got the minus 12 behind. So now I know it's going to go down 12. Again, domain's not going to change. Now, range does change. Again, it's going to be y is greater than, okay, negative 12. Asymptote change. Well, now it's y is equal to negative 12. So whatever the number is, that's what goes there. Really simple idea. All right. Those are actually a little bit easier because there's not a lot of things you're doing. Okay. Example 5 here. Okay, they want us to go ahead and now they're giving it to us in words and they want to put it into an equation. Okay, not too hard here as well. Okay, again, I'm not going to go into everything that we're going to do here. We can just write this equation up. We'll go ahead and write it up right quick. It'd be g of x is equal to, okay, now it says e of x is translated 3 units to the left and 6 units up. So again, if I'm doing this, okay, e to the x, it's going 3 units to the left, so that's actually going to be plus 3 at the top and 6 units up. So that's a big plus 6 behind the exponential. All right. Again, domains not changing. It's all real numbers. Now, again, the range has to do with this. Asymptote has to do with the plus 6. So you guys can figure that out on your own or try to figure it out on your own. Okay. Next one. G of x is equal to, well, let's read this one, okay? Is reflected about the x-axis. So again, that's going to be a negative, okay? The equation will be negative. Vertically compressed by a factor of 1/3, translated down 20 units. So again, it'd be negative, okay, 1/3 here, multiplied by their base, which is 2x. And again, this is down 20, so this is going to be a big 20. These two things, well, the negative does this time. Okay, again, I'll help you out on this one because this one is kind of confusing. All right, but now it's going to be y. Again, since it's that way, it's less than negative 20. Okay, same thing. The asymptote is going to follow follow this information right here. Okay, so you would just have y is equal to negative 20. All right. Couple more things right here. I'm not going to do this one, but 10 to the x is vertically stretched by a factor of 250 and translated up 150. So again, it would be g of x is equal to, and then you would have the 250 times, okay, so on and so forth, and then the up 1500 at the end. Okay, so again, this lesson, just kind of recapping it real quick, it's not necessarily daunting. There are some confusing pieces, but hopefully you guys paid attention and could hear me pretty well and followed along okay. Again, hardest part maybe in my opinion is going from fx to g of x, from words to an equation. Again, you just got to understand where the pieces fall in. Again, your left and right shifts are in the exponent. Your up and down is behind the exponential. All right, and anything else would be in the front, like your stretch, your compression, and your x-axis reflection. That stuff's going to be in the front. Okay, range is all based off of the up and down shifts. Same thing with the asymptote. It's all based off the up and down. If there's not one, it's zero. Okay, it's pretty self-explanatory. Now, I do want to kind of go back over one last thing right here. I'm going to scroll back up. Just talking about our equation and our graph right here on this one again. Again, when you're getting on these, whenever you graph them, remember what is your, not your asymptote, but what is your gosh dang, I can't even think of it right now. Your, come on, your intercept, okay? You start off, all these equations start off at 0, 1. So what happens here is you start off at 0, 1, and then wherever it tells you, that's where you need to move down. Again, whatever the up and down shift is, that's where you draw your asymptote, and you kind of go from there. Just make the graph match up pretty good. Make sure it's going in the right direction, things like that. If you guys got any questions, again, just let me know. But this is lesson 37. Uh, uh, Exponential transformations. So you guys get this written down, and you guys hopefully have a great day.